Hey guys, welcome to day one, and today is a very exciting day because we are going to be creating our very first program. Very awesome, very exciting, and it may look a little bit intimidating. I'm going to throw a lot of things at you. It's going to be a lot of concepts, but today is the day it's going to look the most intimidating ever. Like, it's never going to look more intimidating than it does today. As you go through the series, it will get easier, it will sink in, but today might be a little scary, so don't get scared off. So keeping that in mind, I'm going to go through kind of an overview of what we're going to talk about today, what we're going to talk about the next few days, and with this, hopefully it will sink in later down the road. You do not have to get it right now. It's just kind of an overview for you to see, like, oh, this is how the world of code works. And so what is this overview? Well, everything in real life can be represented as an object, as a thing in code. And so you have candles, you have flowers, you have trees, you have Christmas trees, you have lots of things in real life that you can touch, that you can smell, that you can taste, all of these things, and we can represent this stuff in code. And so say you have this Christmas tree, you want to create, a forest of Christmas trees. Well, you can do this through a class in code. And so in a class, you have properties and methods. I know a lot of terminology here, but stick with me. Basically, a class is a blueprint that helps you create Christmas trees. And how do we make Christmas trees? Well, we look at the object in real life. A Christmas tree has, leaves, it has ornaments, a height of the tree, rings in its tree trunk, stuff like that. And we can represent that in code inside of our class. So stuff like, the height of the tree, how many ornaments it has, those are properties. Those literally define what the tree is. And things that change those properties, maybe you have, a way to grow the tree, or you can remove ornaments or add elements. Those are things that change the properties of the tree. They change what defines what a Christmas tree is. And those things are called methods. And so grow tree would, grow the tree. It would change the height, and the height is a property of the tree. Or remove element would change the number of ornaments on this Christmas tree. Stuff like that. So this is big concepts here, big concepts. You have objects in real life. They're represented as blueprints in code called classes. These blueprints create instances. They create the Christmas trees, and the blueprint inside of it are properties and methods, and properties define what the thing is. Methods change the value of those properties. And how do we even represent, the height of the tree, the ornaments of the tree? Well, we use data types, and that's a whole other thing. But for right now, just get the fact that there are objects in real life. We can create classes to make those objects. Those classes contain properties and methods, and those properties are defined through data types. And so this is a lot of terminology. This is kind of really big picture stuff. I'm going to go through more detailed, more examples later on, but just try to wrap your head around that. So now we can begin. Awesome. So to get started, we are going to open NetBeans, and that's the software we downloaded last time. And basically, that is where we are going to write all our code. So you can go to Spotlight or your dock or wherever you have it, open it, it'll load. And again, this is where we're writing our code, and it has a bunch of things that will help us do that. And so just a reminder, we are programming in a language called Java. And it's a very common language. Usually if you know Java, you can pick up anything else. And it is an object-oriented programming language, which basically means that everything you create is an object. And so if you think of objects in real life, there's tables, chairs, markers. Basically anything you can think of that's a thing in real life, you can represent somehow in code. And so in Java, you have these different objects, and they have properties. So a marker has a color property, and maybe like a life property, where if you hit the marker too hard, it's running out of life, or something like that. And with these properties come abilities to change them. So again, you have a blue marker. If you color something extra dark, it may not be blue anymore. With code, we can actually represent these objects, their properties, what you can do to change their properties, and that's the basis of object-oriented programming. And so right now we have nothing. We have a blank screen, nothing's there, and so we should create something. And so how do we create things? Well, we'll just go to File, and we'll create a new project. And we are going to create a Java application right here, because we're programming in Java. And so you'll hit Next. And we are going to create a car. So like I was saying, all objects in real life can somehow be represented in code and how accurate their representations are depend on what you write. And so we're going to call this car, and it'll create a class for us, which it's a fancy term. We'll learn about it later, and I'm just going to put it here on my desktop. If you want it somewhere else, you should click Browse and put it where you want it to go, and we'll click Finish, and it will create. It might take a little while because it's our first new project, but that's okay. And you have created your first file. Congratulations, we have our first project, our first file. This is really exciting. Everything's working out right now. And so we can just take away some of the stuff. We don't need that thing at the top. We can take away some of these comments, which I'll talk about later. And we have this thing called a class. There's kind of a lot of stuff here. There's this word public, there's static. What do these mean? We'll talk about it later. But for right now, just think about how this file is going to represent a car object. And so somehow in this file, we are going to create a blueprint for a car. So this is our blueprint, and then we're going to give it to a bunch of people, and they're going to make their own different individual cars. We can think about how we represent a car in real life. And so we may have a max speed, a minimum speed, a weight of the car, maybe if the car's on or not, we have a property that says that, maybe like a status for the car, like what conditions it's in. So say it has 2 flat tires, and so that's a B condition because you still have to get stuff fixed on the car. And so how do we actually represent things with code? Well, we have data types, and there are several different data types that we can use to represent things. And these are kind of like our baby steps in representing our car. So the first type of data types are primitive types, or also called value types. And they are the most basic of data types that you can get. And so basically there are 3 big things. They're numbers, Booleans, and characters. But without talking too much, let's try to make some properties for this car. And so we know speed is going to be a number, so that's going to be a primitive type, a value type. And so we can actually do int, which just means integer. So that is the data type for whatever we're going to type next. And so we'll say max speed. And so we have int, the data type here. Our property is going to be max speed. Cool. We just created our first property. Yes, okay. And so we also said that we can do a min speed. And so we can do int min speed. And it's kind of hard to read right now, and so we could actually capitalize the second word. And by doing that, we're doing something called camel casing. And a lot of people do camel casing because it's easier to read and it's a common trend in programming. So right now we have numbers, but they can only be represented as integers. And by integers, we mean negative to a certain number and then positive to a certain number. And they can't be fractions, they can't be decimals, they must be whole numbers. But what if we want to do a decimal? What if we want to do like a weight of the car? But the weight tends to be not an integer. It's usually between 2 numbers, somewhere in the middle. How do we do this? Well, there's another type of primitive type that's also a number, and that's called a double. And this is the default for decimal values. So we can just do double, and then we can say weight. And now we have a property called the weight of the car. And these are also called fields. They can be called properties fields of your object. And the reason why you have these little semicolons here, you might be wondering, it's just syntax, you know, it's just something that helps this thing compile, that helps it run, that makes it work. In the end, you just got to use them. And so I'm going to do Command S to save here. And another type of number that you can use is a float. And so instead of a double, I can do a float. But a float is a little bit smaller than a double in size, meaning that it takes up less space. And by space, I mean bits, and we'll talk about that later. But for right now, we'll use a double. And so I also talked about a Boolean and a character earlier. And so for Boolean, we just do Boolean, exactly how it sounds. And a Boolean is something you say yes or no to, true or false. It is a simple yes, no, true or false thing. So we want to know for our object car is it on? And so we can literally call it is the car on with our camel casing. Do a semicolon. There we go. And basically we can assign this true or false, and when it's evaluated, we'll know if the car is on based on how we set it. And so this can be really nice. So instead of doing an int and doing like a 0 or 1, we can literally say true or false. Very, very nice. For our last property that we'll create, we'll do a character, and that is denoted with the keyword char. And this will be like the condition of the car. So you can have like an A, B, C, D, F if the car doesn't turn on, condition. And so we'll just say condition. And this will be a character. So these are our primitive types, value types, core of programming right here. We have integers, which are whole numbers, floats, doubles, which are decimals, Boolean, which is true or false, yes or no, and then we have our character, which is just like an A, B, C, and it can also actually be like a star, like an asterisk, or an and sign, a ka-ching sign, what is that called, dollar sign, and it can be any type of character, but it can only be a single one. It can't be like a string of characters. Now with our value types and primitive types in order, we can actually assign values to these. And this is going to change the way you think about math forever. And so usually in math, 1 + 1 = 2, but not here. What do I mean? Well, we're going to delete this little semicolon here, and we are going to put in a space, an equal sign, and what should our max speed be? Let's say 100. Put in that semicolon, and what this does is this assigns the value 100 to max speed. And notice 100 is a whole number, so if I do 100.01, it's going to error because, let's see the error. It says change type of max speed to double, because double, again, is the default for decimals. And so we want a whole number for our max speed, so we'll take that away. And so back to what I was saying, this is the assignment. It doesn't mean equal, it means assignment. And so we're assigning 100 to this value of max speed, and we'll prove that later on. And so we'll kind of assign the rest of the things here. We'll go equals 0 for our min speed. Our weights, we can look up the average weight of a car real quick. So we'll say weight of average car. Hit enter. That is our number. So we'll do 4,079. And we'll close that. And that's in pounds, and so sorry for those that don't use pounds. But that's what we're doing. And so now we'll say, is the car on? We'll say false. And notice if I try to put a number here like 0 or 1, it will freak out and say, oh, you want to cast it to an int. And casting just means forget the fact that this is 0, we're just going to cast it as a Boolean. And you don't really want to do that for primitive types because they're pretty solid on what they are. But when you get to bigger things that aren't primitive types, which they do exist and we'll talk about later, you may want to do that. But again, later topic. Right now we want to say false here. We want to do what the compiler wants us to do. Our condition, we have a pretty good car, so we'll say quote A end quote. And now our properties are assigned. So with our blueprint of a car, we have kind of the average values here for a regular car, and they can be changed whenever we want. Now we can actually check if these properties are what we think they are. And to do this, we have to create a function. And so function is a pretty big thing, so I'm not going to go too in depth right now, but just kind of follow along and hopefully you'll catch on. And so we are going to write public, which is the scope of the function. We'll talk about it later. Then the return type of the function, which is going to be void because it's not going to return anything. And then the name of the function, which is going to be print variables. We'll open, close paren, open bracket, hit enter. That'll close the bracket. And then we'll actually print these out to the console so we can actually see what they are. Is max speed 100? Is the car on? Stuff like that. We can find out by printing these variables, properties, fields to the console. So to do this, we'll do system.out.println, open paren, and then whatever value we want to print out to the console. And the console is just like a little window at the bottom of the screen that will literally show whatever value you print out. And so we'll say max speed. Then we'll do semicolon, then we'll write this whole thing out again, but for each property. So we'll do system.out.println. No, there's not an easier way to do this if you want each value. So we'll do system.out.println, wait, system.out.println, is the car on, semicolon, system.out.println, condition. There it is. Everything's ready. Now, if we run it, nothing's going to happen because we're not calling print variables. How do we call this method? Well, we have to create an instance of the car class in order to call it. Right now, we have a car entity. We have the blueprint, we have the plans to make a car, but we don't actually have a car yet. To build a car, we have to create an instance of it. So we can create an instance by doing car down in our main function, which is going to be run instantaneously as we run the entire thing. So we have car, and then the name of our car, we'll say Kari. Then we'll do the equal for assignment, and we'll just say new car. This is creating a new instance from our blueprint. It's creating a new object. We have the plans, we're creating the object. And so on Kari, we can do dot. And notice if we kind of go through all this stuff, this is a bunch of given methods for any object. But we actually created a custom one called print variables. We'll hit enter. There it is. And now we can run our first application. Very exciting. And so we'll do Command S to save. We'll run it by clicking this little arrow up here, the play button. And so we'll run it. And down here, all of our things are what they're supposed to be. If you look up here, our max speed matches up with this. Our 0 matches up with that. And to prove these are actually printing out like they're supposed to, we can add a little note here that's called this is the max speed. We can do a plus here. We can run it again, and it says this is the max speed. They're right next to each other because I didn't put a space here, so I'll put a space, run it again. You can run it as many times as you want. If you don't change the code and you keep running it, it's going to print out the same things. The reason that each of these printed out on different lines, except this one printed out on the same line, is because I did println. And println just says, okay, print this out, and then the next thing you print out, we're going to do it on the next line. And so that's printing things in your console. Again, super useful if you want to know what the values of your properties and fields are. So besides primitive types, there's another type of data type that is out there in the world, and it's called a reference type. And a reference type does a shared copy. So say you have a car that's shared by multiple owners. Each time you reference the car from any of the owners, you want it to be the same car. So say one of the family members paints the car blue. Well, when you access it from a different family member, you want it to be blue because someone else changed it. It's the same instance of the object. So as an example, we can change the variable name here, Kari, to family car. And this will stand for the family car that the whole family owns. And so because we changed the variable name, we have to go down here and change this to family car as well. Now let's say Alice is a member of this family and she's over 16 and has a driver's license, and so the family car is also her car, or at least the car she uses to get around wherever she needs to go. And so we can say car, Alice car equals family car, because her car is the same as the family's car. Now let's change something about the family car. We can create a new method or function here and just follow along. We'll talk more about functions later, but we can say public void change condition. Open bracket, close bracket. And let's say a different family member wrecks the car, and so now the condition has changed from A, which it was originally up here, to say C. It's not totaled, but there's some damage. And so we can say change condition is our method, and we can say condition equals C. And instead of change condition, we can actually just do wreck car. And whenever you wreck the car, the condition gets dropped to C. And so now we can call this on the family car dot wreck car. And this will change the condition from A, which it was originally, to C. Then we can call Alice car dot print variables, and we can see if Alice's car has been affected by this change. What should happen is because a different family member wrecked the car, Alice's car should have the condition C as well. It shouldn't be A, it should be C, because her car, which is the family's car, got wrecked. And just to make this a little clearer, we can add a system.out.println, and we can put a little note here that says Alice's car. So it's easier to read in the console which set of variables is Alice's car. And we can also add it up here to system.out.println, and we can say family's car. And just kind of clean it up here, add a semicolon, and now we can run it. And it'll run, So everything up here is the same. We printed out the original variables to the family car, but now we made Alice's car equal the family car, someone wrecked it, and now Alice's car, which is the family car, has the condition of C rather than A. And this is good because Alice's only car is the family car. But this works only for reference data types. Primitive data types don't do this. So instead of wreck car, what if we say upgrade min speed? And we'll say this function makes the original max speed the min speed. And so we'll want to do min speed equals max speed. So we'll make the min speed be the max speed. So here, if we look in our console right here, our max speed was 100 and our min speed was 0. After we run this function, our max speed will stay the same at 100 and our min speed will be 100 as well. Now we'll increment max speed and we can do max speed equals max speed plus 1. And so what should happen is min speed gets the 100 from max speed and max speed gets its original value 100 plus 1. So min speed should be 100 and max speed should be 101 after we run this function. Now with our function done, we'll change this to upgrade min speed. And we'll take away Alice because we don't need her anymore. And we'll take away this. And we'll add a print variables after we change the min speed. And then we'll save, play it. And notice the first time we do it, the max speed is 100, everything's the same. But when we do it the second time, here, the max speed is 101 and the min speed is 100. So it worked the way it was supposed to. If this was with references, then the min speed should be 101 because here we changed the max speed. But that's not the case because this is a primitive data type, and these variables are completely independent from each other. But notice when I changed things with a family car, it also changed things with Alice's car because it was referenced. I know this may seem super abstract and kind of out there and not really important right now, but it is really important because when you start changing things in your code, knowing if something is a referenced or primitive data type can help you avoid mistakes and avoid changing things that are linked to other things that you may need later and not want to change. Some examples of reference types are actually arrays, queues, linked lists, stacks. You may not know what those are right now, but that's okay. They're just data structures. And our car here that we've made is actually a data structure because data structures are just composed of primitive values. So again, our ints, doubles, booleans, characters, stuff like that. And we can actually add a reference type right into our code. And so say we want to give our car a special name. So we'll hit enter. And we can create a string, which is just a list of characters, and name our car. And so we'll say the common blueprint name for a car is Lucy. And so we'll say string with an uppercase, and we'll say name of car, because it's going to be the name of our car, equals, and then we'll say Lucy. And we'll do it with double quotes because a string is with double quotes, a character is with a single quote. This matters in Java, but it doesn't matter in some other languages. So we'll save. A reference type works just like a primitive type, and here in our print variables we can just add system.out.println and we can print out the name of our car. So we can just say name of car, add a semicolon, save, print it out, and Lucy is right there. So in this video we talked about data types, referenced versus primitive, ints, bools, floats, doubles, characters, strings, all of them. Very exciting. And we also played with printing into the console as well as with a couple methods. So thanks for watching this video. I hope you learned something new and that it wasn't too intimidating or scary or anything like that. I promise it will get easier with time. You just gotta keep looking at it, keep thinking about it, and it will eventually sink in. If you wanna keep messing with the code, check out the HackerRank challenge down below in the description. As you know, every day is going to be accompanied with a challenge, and so you can test out your skills right now. I talked about this a little bit in day 0, so go back to that video if you want to know more about what they're about. And yeah, so if you have any questions, feel free to leave them down in the comments and I will answer them, and I will see you tomorrow.